Alright, so the next question asked is y equals x squared minus 4x plus 7 equivalent to this one. Well, let's see. When I multiply out the x minus 2 squared, I get x minus 4x plus 4, and then the plus 3 makes it plus 7. So this would be yes, because when we multiply it out, we get the same thing. So remember, anytime you square something, you multiply it by itself. That does not give us x squared minus 4, x squared plus 4. You have to FOIL or box that. Next, write the equation represented by the graph. So the first thing you have to do is find your min or your maximum, and then you find your a value. Your a value is the difference between your first 2 points being your vertex and the point right after your vertex. So here my vertex is at 4, 3, and my a value is negative 1. On this one, my vertex is at negative 5, negative 2, and my vertex is positive 2. That gives me the equations of y equals negative x minus 4 squared plus 3 and y equals 2x plus 5 squared plus 2. You can multiply those out to put them in standard form if requested. Next, what if you're told to determine the quadratic equation from a table? This is whenever we use our calculator to find our equation. The steps, if you remember, are as follows. We go to Stat, Edit. We enter the tables L1 and L2. Our X values go in L1. Our Y values go in L2. Then we hit Stat over the right arrow to calculate. Choose option number 5 for quadratic regression and hit Enter. And then hit Enter again on Calculate. It will give us our values for A, B, and C, and then you can write your equation. Then you can take the equation and put it in the table or graph it if need be. So let's look at the first one using our calculator to find these two equations. We'll do the first one together and then I'll let you do the second one. So stat, enter. If there's anything in there, you can type over it or you can clear it out. This is 0, 3, 5, negative 7, 2, and 28. Stat over to calc, option 5 gives us quadratic regression. I want to calculate. So my equation is y equals 2x squared minus 3x minus 7. Take a few minutes and try the second table and see if you can figure out its equation. Please pause this video while doing so. The second equation is negative 6x squared plus 4x plus 1. If you have any questions on how to plug this in the table, please ask Miss Lewis now. Next, you may be asked to compare functions. So when it says approximate, remember that means we are rounding. So you're going to approximate the difference between the maximums of f of x and p of x. So that means you're going to do f of x minus p of x, because that's the order, and difference means to subtract. You are given an equation in a table, so the first thing you have to do is find their maximums. In the table, you find the equation. Then you can do negative b over 2a to find the vertex and plug that in to find your y. Or you can type it in the calculator and y equals and look at where the maximum will be. Same thing with p of x. You can solve it by hand using negative b over 2a and then plugging that answer in. Or you can look at the graph and find the maximum. Then what we're going to do is do f of x's max minus p of x's max, which gives us our difference in maximums, or 15 minus 22.5 is negative 7.5. Remember, you always do it in order of the problem, so ignore that little mess right there. Next, try finding the approximate difference between minimums of f of x and g of x. So pause the video now and try this problem on your own. Hopefully, on 31, you got the equation for the table to be 2x squared plus x minus 10, and your minimum being negative 10.1. And then in g of x, your minimum is at 5. So then negative 10 minus that 5 is negative 15.1. Remember, order matters. Next, we're going to look at some word problems and pay attention to how to do those. April shoots an arrow upward at a speed of 80 feet per second. So that's our velocity. Remember, this number in the middle, our B value, is always our velocity at the beginning. So our initial velocity. Off a platform of 25 feet high. So that's our initial height. So that's our C value, is our initial. The pathway of the arrow can be represented by this equation. Remember, negative 16 is there because that is a conversion factor of the rate of gravity, where h is the height and t is the time in seconds. What's the maximum height of the arrow? That would be at 125. Again, you can do this multiple ways. You can type this equation in your y equals and find the maximum by using your calculator. Second trace option 4 is your maximum. You can also use negative b over 2a to find your vertex x point and then plug that x into your t values and also get 125. The second question asks, how long was the arrow in the air? And that means it starts at one point and it goes to the other. So that's asking how much time has gone by to here, this 0. That is at 5.3 seconds. Again, there are multiple ways to find this. You can use the calculator to find the 0. You can use the quadratic formula to do it by hand. Either option is up to you. What other wording can describe the amount of time the object's in the air? Could also say how long before it hits the ground, or when did it hit the ground. If you have any questions about the real life examples, now's the time to ask Miss Lewis. The last thing we're going to talk about today is solving quadratic systems. Remember, there are 3 ways to solve a system. That would be graphing, substitution, or elimination. And the main things that we do are graphing and substitution, just because those are the 2 easiest. When graphing, remember, we're looking for the intersection of the 2 graphs. So graph both functions in y equals at the same time. Second trace option number 5 is the intersect. Then you move your cursor to the intersection point, hit enter 3 times, and it will tell you the answer. For substitution, we're going to solve the simpler equation for either x or y. In this case, because we're doing x squared polynomials, more than likely it's better to solve it for y. Plug that equation into the other equation and solve. Substitute your answers back into your original equation to get the coordinate pair. Remember, no matter what, when you graph or substitute, the solution to a system is an ordered pair, an x and a y. And for most of these, you're going to have 2 ordered pairs, not just 1. So now let's look at some examples of systems of quadratic equations. The first couple we're going to do by graphing. They're already in y equals, which makes our life easy. So negative x squared plus 3x plus 2 and 3x plus 1. If you notice, this is a quadratic with a line. And we're going to look at the graph. There's our quadratic. There's our little line. And we're going to see how many times they intersect. So second trace 5. I want my cursor near where they're going to cross. Enter 3 times tells me it's at 0, 2. Now, could it cross more than once? Of course it can. Does it look like it? Kinda, maybe, I'm not sure. If I go to my table, the intersection is where the y values are the same. So if you look right here at 0, they both have 2's. Everywhere else, the numbers are different. Remember, the rate of change of a quadratic is a lot faster than the rate of change of a linear equation. Here it's just going up by 3. Here it's going up by a kind of exponential amount. So there's only one solution of 0, 2. The next one is a quadratic and line again. So if I go to y equals and type that in, x squared plus 2x minus 3, 2x plus 1. If I look at my picture, there's my beautiful parabola. There's my line. Hopefully you can tell there are 2 solutions. It does not matter which order you find them in. Second trace 5, go over to the intersection 3 times. Negative 2, negative 3 is an option. Do it again. Go over to the other intersection this time. And 2, 5 is your answer. If you have questions about 33 and 34, now's the time to ask. Otherwise, try the next two on your own and ask Ms. Lewis for any help before checking your answers. Please pause the video now. The answers you should have gotten for the two quadratic systems in 35 is 0, -3. They only have their vertex in common. And 36, you should have gotten -1, 0, and 3, -4. Again, if you did not get these answers, or if you have any questions about solving systems by graphing, now is the time to get help on that from Ms. Lewis. Solving it by any method of your choice. So let's look at these, because these are just the answers that we have. I'm going to show you how to do this with substitution, and then you can solve the other one however you choose. Substituting means we are going to take this equation and literally substitute it in for y. Because both of these say y equals, I can say x plus 1 equals 2x squared minus 3. Then you're going to get the x on one side and solve it. The easiest way to do that is to move the smaller variable. So that gives me 1 equals x squared minus 3. I'm going to add 3 to both sides, trying to get that x squared by itself. To completely get x squared by itself, I take the square root. So that tells me x is plus or minus 2. When I plug in positive 2, I get a 5. When I plug in negative 2, I get a 5. So my two solutions are -2, 5, and 2, 5. In 38, it is up to you how you choose to solve it. You can solve it using substitution, which is what I did here. In this case, you're going to have to do a little bit of factoring. Or you can use your calculator in y1 and y2 and find the intersection. If you have any questions about solving these by hand, please ask. The last few examples are word problems that we're going to work through. The first one talks about numbers and their sums and their square of their sums. It was solved by hand because you cannot do y squared in your calculator. So it says the first one, the sum of two numbers is 9, so x plus y is 9. The sum of their squares is 41, so x squared plus y squared is 41. I solved it using substitution, and you can see the work there. Or if you are one of those people, you can also guess and check answers. So do 5 and 4, give me 9. So then 25 plus 16, there are my answers. So it will be 4 and 5 are my answers. The second one works out the same way. You just have the sum of two numbers is 17. Their sum of their squares is 149. Again, you can guess and check, or you can use substitution, which is a long way. In 41, it is a real-life application problem, not just one where we kind of manipulated the problem for you. It says two skaters are practicing at the same time at the rink in a ring. One skater follows a path of a line, the other one follows a curvy path. Find the points where they might actually collide if they're not careful. So where they collide, that's just fancy for their intersection. So that's 228 and 816. Again, whenever you do these, it's up to you how you choose to solve them, whether it be substitution or elimination. Just be careful. And then on 42, you're asked where the break-even point is. Which is meaning there's zero profit is another way to say that. So that's where does it intersect with 0 or the x-axis. So you would type this in y equals and then figure out when that happens, which is at 3.78. If you have any questions on the word problems for quadratics, now's the time to ask. Spend the rest of this time asking Ms. Lewis questions about quadratics and completing the quadratic homework. You should also get a flow chart with all this information on it about quadratics, the different forms, and other information that you need to know, including transformations or anything that could be asked on your state exam. If you have questions, again, please ask Ms. Lewis.